So we're not doing like a combination of three functions, it's a combination of two functions. So we take a function f of x and g of x, right? Such that they're both defined and makes sense to add them. In fact, any two functions can be added. The restrictions come with other operations. So if you think of the function f of f plus g of x, so this f plus g is a function. This function f plus g of x is the same really as taking the function f of x and add it to the function g of x, right? That's all. So an example would be if I have f of x is equal to x squared minus 7, and I have g of x is equal to, use a different color, g of x is equal to 7 plus sine x. Alright, then f of x plus g of x, or f plus g of x. F plus g of x will just be the function x squared minus 7 plus 7 plus sine x. I don't need any parentheses because I'm adding, right? So I'm adding here. And so if I add these 7, negative 7 and 7 cancel out. And so that function is just x squared plus sine x, okay? I might not want to use that example. Okay, so let's not use sine x. Let's say x squared plus, let's say 7x plus x cubed. We run into some problem if we use sine x here, because there's going to be some overlapping which might not make it a function. Alright, so again we take a function f of x equals x squared minus 7, and we take a function g of x equals 7 plus x cubed, and we look at the function f plus g of x, and we see that it's going to be x squared minus 7 plus x cubed, which is going to give us x squared plus x cubed. Alright, we can also take the difference of two functions. So if I have a function so f minus g of x is f of x minus g of x. So this is a function right here. This is one function, and it's made up of these two functions. So if I have f of x is equal to x squared minus 3 over 17x, and I have g of x is equal to square root of x minus 7, let's say that x squared, x squared means square root of x minus 7. Okay, then the function f plus g of x is just going to be x squared minus 3 over 17x minus, sorry, this is minus square root of x minus 7. That's just what the function is going to be, alright? Got it? And then the easiest example here for this will just be two polynomials. So if you have the function fg, which is f times g of x, is just the same as f of x times g of x. And so let f of x here equals x plus 2, f of x equals x plus 2, and g of x equals x plus 3. So we have those two binomials. Then f g of x, product function here, is just going to be x plus 2 times x plus 3, which we also know as x squared plus 5x plus 6, okay? That's how it works with multiplication. Alright. And now we also have a quotient. So we also have a quotient. So and these are important because that's how we get to get like rational functions. So let f of x be equals to 4x, and let g of x be equals to x minus 2, and provided notice g of x cannot be equal to 0. So here we want to define g of x as x minus 2, right? And we want to bear in mind here that we're in it, especially for the next step, we're going to consider that x is not going to be equal to 2. That's not going to help us. So then f over g of x is just going to be equal to 4x over x minus 2, where x is not equal to 2. Why is x not equal to 2? Okay. Alright, so here we have some examples. So here's the first example. You can think about this while I get the questions. So we have f of x equals x minus 5, g of x equals x squared minus 1, and we are trying to find the following. Alright? We are trying to find f plus g. Okay, we're trying to find f plus g of x. So how about we just pause the video and you do this. Okay. So again, we have f of x equals x minus 5, g of x equals x squared minus 1. And we want you to find f plus g of x. Okay. We want you to also now state the domain. State the domain of f plus g of x. Okay, so this is your turn, your turn. Then f of x equals